Hi everyone, in this video we'll discuss how to flatten a multi-level doubly linked list. So we are given a doubly linked list where each node has three pointers: next pointer, previous pointer and an additional child pointer. So this child pointer will point to a separate doubly linked list on the next level. So we are given the head of the first level of the list. We need to flatten it so that all the nodes appear in a single level doubly linked list. Let's see an example. So here A is the head of the linked list. We can see that each node has three pointers. So this is the next pointer, this is the previous pointer, and this down arrow is the child pointer. So for some nodes this child pointer is null, whereas for nodes C, G, J and L we have a valid child pointer. So this child pointer points to the next level of this doubly linked list. So we are given this list and we need to flatten it so that all the nodes appear in a single level linked list. If we see the output of this example, it will be something like this. So we start the traversal from head of the linked list. So we go from A to B to C. Then at C we see there is a child node. So we process all the childs of C. So we have G and K. Once we process all these child nodes, we go back to G and process all the next nodes. So we have H, I and J. Then at J again we have child nodes. So we go down to the child nodes and we process L and O. Once we are done with L and O, we come to the next of L, which is M and N. Once we are done with N, we go back and we process the remaining nodes of C, which are D, E and F. So the resultant list that we obtain is a doubly linked list which has no child nodes. So there is only one level in the resultant linked list. Now there are various methods to solve this. In this video we'll discuss the iterative approach to solve this. Now let's understand the iterative method. So if we see the output that we want to obtain, so first we'll start from A. So we'll go to the next of A, B and C. At C we see there is a child node. So we process the childs of C. So G and K are the child of C. Now once we process the child nodes of G, we need to process the next nodes of G, which are H, I and J. So one thing is clear, whenever we see a child, we need to process the child nodes. And then we need to process the next nodes. So we need to store the next pointer so that we can come back to it once we are done with the child nodes. And when we are going down to the child nodes, we are going deep until we encounter a null. So from C we go to G. At G we again see there is a child, so we go to K. So this seems like a DFS approach, which is depth first search. So as long as we see a child, we'll keep traversing it until we reach null and then we'll go to the next pointers. So this is a DFS approach. And for DFS approach, the data structure that we choose is stack. So in this iterative method, we'll explore how we can solve this problem by using stack. Let's see how we can do this. So we keep a stack and we push the head node on the stack. So we are pushing A on the stack. Now we traverse till the stack is not empty and we keep track of two pointers, current node and previous node. So current node is top of the stack, which is A, and then we pop from the stack so the stack becomes empty. Then we check if current node next is not equal to null. So next of current node is B, so we push B on the stack. We check child of current node, so as A has no child, so this condition is false. Then we set current node child equal to null. Because in the result we want to obtain a flat linked list, so it should have a single level. So while traversing, we'll set child pointers for all the nodes to be null so that we can have a flat linked list. So here we are setting current node child equal to null. Then we set current node previous equal to previous node. So previous node is null. So basically here we are setting previous of A to null. So since A is the first node of the linked list, previous is already null. Then we check if previous node is not equal to null. So in this case, previous node is null, so this condition is false. And then we set previous node equal to current node. So previous node becomes equal to A. Now we come to the next iteration and we set current node to top of the stack. So current node becomes equal to B, and then we pop from the stack. So stack becomes empty. We check next of current. So next of B is C. So we push C on the stack, and then we check child of B. So child of B is null. So this if condition is false. Then we set child for B. So child of B is already null. And then we set current node previous equal to previous node. So we are making the link from B to A. Then we check if previous node is not equal to null. So we set next of previous node to current node. So we are making the link from A to B. In the next step, we set previous node equal to current node. So previous node becomes equal to B. In the next iteration, current node becomes equal to top of stack, which is C, and we pop from the stack. So the stack becomes empty. Then we push next of current node, which is D, and then we push child of current node, which is G. We set current node child equal to null. So basically we are removing this link. So child of C becomes equal to null, and we are setting current node previous equal to previous node. So current node is at C, so we are setting the link from C to B, and we check if previous node is not equal to null. So we make the link from previous node to current node, so we are creating the link from B to C. And in the next step, previous node becomes equal to current node, so previous node becomes equal to C. Now in the next iteration, current node becomes equal to top of stack, so current node is G, and we pop from the stack. We check next of G, which is H, so we push H on the stack, and then we check child of G, which is K, so we push K on the stack. We set child of G equal to null, so we are breaking this link from G to K, and we are making the link from current node to previous node. So current node is G, so we are making the link from G to C, and then we are creating the link from C to G. And then the previous node becomes equal to current node, so previous node becomes G. So here you can see that we have saved the pointer to D in the stack, and we are processing all the childs currently. So that is why in the stack we first process the next node, then we process the child node. Because stack works in the reverse order, so we push child node after the next node so that child node can be processed first. In the next iteration, current node becomes equal to top of stack, which is K. Then we pop from the stack, so we remove K. Then we check next of K. So next of K is null, and then we check child of K. So child of K is also null. Then we set child of K to null, which is already there, and then we create a link from K to G. So current node previous equal to previous node. So now we are creating the link from K to G, and in the next line we create the link from G to K. And we set previous node to current node, so previous node becomes equal to K. In the next step, we check top of the stack, which is H. So current node becomes equal to H, and we pop from the stack. Then we check next of H. So next of H is I, so we push I on the stack. Then we check child of H, which is null. So this if condition is false. We set child of H to null, and then we set current node previous equal to previous node. So current node is H, so previous of H becomes equal to K. So we are creating a link from H to K, and then in the next line we set previous node next to current node, so we are creating a link from K to H. And then previous node becomes equal to current node, so previous node becomes H. In the next iteration, current node becomes equal to top of stack, which is I. Then we pop from the stack, and then we push the next of I in the stack, which is J. And we check child of I, which is null. We set child of I to null and current node previous equal to previous node. So we are creating the link from I to H and from H to I. and then previous node becomes equal to current node, so previous node becomes I. In the next iteration, current node becomes equal to top of stack, which is j. Then we pop from the stack, so we pop j. Then we check next of j, which is null, and child of j is L. So we push L on the stack. We set child of j to null, and then we set current node previous equal to previous node. So previous of j becomes I, and next of I becomes j. And then previous node becomes equal to j. In the next iteration, we check top of the stack, which is L. We pop from the stack, so we remove L from the stack. We check next of L, which is M, so we push M on the stack. And we check child of L, which is O, so we push O on the stack. We set child of L to null, and we set current node previous to previous node. So we create a link from L to J, and then in the next line we create the link from J to L. And now previous node becomes equal to L. In the next iteration, we check top of the stack, which is O. So we remove O from the stack, and we check next of O, which is null, and the child of O is also null. Then we set current node previous to previous node. So we create a link from O to L and from L to O, and previous node becomes equal to O. In the next iteration, current node becomes equal to top of stack, which is M. So we remove M from the stack, and then we check next of M, which is N. So we push N on the stack, and we check child of M, which is null. Then we set child of M to null, and we create a link from M to O and from O to M. And now previous node becomes equal to M. In the next iteration, current node becomes equal to top of stack, which is N. We remove N from the stack, and we check next of N, which is null, and child of N is also null. So these two if conditions are false. We set child of N to null, and we create a link from M to N and from N to M. And then previous node becomes equal to current node, which is N. In the next iteration, current node becomes equal to top of stack, which is D. We pop D from the stack, so the stack becomes empty. We check next of D, so next of D is E, so we push E on the stack, and then we check child of D, so child of D is null. Then we set current node previous to previous node, so we are creating a pointer from D to N. So previous of D becomes N, and next of N becomes D. And in the next step, previous node becomes equal to current node, so previous node becomes D. In the next iteration, current node becomes equal to top of stack, which is E. Then we pop from the stack, so the stack again becomes empty. We check next of E, so next of E is F, so we push F on the stack, and we check child of E, which is null. Then we create a link from current node to previous node. So we are creating a pointer from E to D and from D to E. And then previous node becomes equal to current node, which is E. In the next iteration, current node becomes equal to top of stack, which is F. We pop F from the stack, so the stack becomes empty. We check next of F, which is null. Child of F is also null, so these two if conditions are false. Then we set current node previous to previous node, so we are creating a pointer from F to E and from E to F. And then we set previous node to current node, which is F. In the next iteration, we check this while condition while stack is not empty. So the stack is empty now, so this while loop terminates, and at the end we return head. So head is pointing to A. So if we draw all the red pointers that we have here, we'll get this linked list. So this is the flattened version of this multi-level doubly linked list. So if we talk about the time and space complexity, the time complexity is order of n, where n is the number of nodes, and the space complexity can maximum be order of n. So once we have understood this algorithm, let's have a look at the implementation. All the source code that I'll be showing is available in my GitHub repository. link of which is present here and as well as in the description. Now let's have a look at the code. So in the main function, first I create the linked list. So I've created this linked list which I've shown on the left side. Once I create the linked list, I call this function flatten iterative, in which I pass the head of the linked list. In this function, I first check if the head is null, then I return null. Otherwise, I create a stack and I push the head node in the stack. I create two pointers, current node and previous node, both are initialized to null. Then I have a while loop in which I iterate till the stack is not empty. I check the top node from the stack, I pop it, and then I push the next node and the child node in the stack. I set the child pointer to null because we have to obtain a single level linked list, and then I create a pointer from current node to previous and from previous node to current. So once the while loop terminates, I return the head of the linked list. So head of the linked list will remain unchanged because the new linked list will also have the head as the original linked list. Now let's see the output of this code. So this is the flattened version of this linked list. Now this problem is also available on lead code as question number 430, flatten a multi-level doubly linked list. I pasted the same code here and it is success. Now here we have solved this question using iterative method. In the next video we'll see how we can solve this using recursion. So that was all for this video. If you have any doubts or suggestions, please leave in the comment section below. If you like my content, please do like, share and subscribe to my channel. It really motivates me to make more such content. And until next time, this is Sandeep Thapar signing off.